Hi everybody, Mrs. Pesic here. I am live with Block 8. Do you want to give a shout out, Block 8? All right. Okay. All right, we're looking at section 12.6, and I have some notes for you. All right, so in section 12.6, the topic is segment relationships in circles. And your goals are to find the lengths of segments formed by lines that intersect circles and use the lengths of segments to solve problems. Let's take a look at our first theorem. It is called the chord-chord product theorem. And it says if two chords intersect in the interior of a circle, then the product of the lengths of the segments of the chords are equal. So in this diagram, we see that we have chord AB and chord CD intersecting at point E. And this section, like section 12.5, was all about angle measures related to a circle and chords and secants and tangents. And this whole section is about segment length. So last section was angle measures and arc measures, and this one is segment lengths. All right. So in this case, they're telling us that segment AP, if I take that one times EB, that's going to be equal to CE times ED. So that's AE times EB is equal to CE times ED. Are we okay with this? For example, if I tell you that CE is 5 and that DE is 12 and that BE is 6, how would you find the length of segment AE? I'm going to get you to help me. Alex? My made-up example here. All right, so 6 times x has to equal 5 times 12. So I get 6x equals, is that 60? Yeah. So x is equal to 10. Are we okay with this? All right, let's do a little bit more practicing with this. In this case, we've got this diagram. Is this on your notes? Yeah. All right, so can you help me out? How am I going to find the length of x here, Devin?
I did 8x equals 24.
8 times x has to equal 4 times 6. So 8x equals 24. So x equals 3. And if x is equal to 3, can you help me out with the length of PR, Isabella?
I would do,
I think you're thinking too hard. What's the length of segment PR?
oh, it's
10. Sure. So 6 plus 4 is 10. And how about the length of segment ST, Connor?
Oh, sorry, I moved on. 11.
11. Are we okay with this? Yeah. All good? So just to show that just because the products of the segments are equal doesn't mean the segment themselves are equal. Does that make sense? Okay,
Yes.
Does that make sense? What I just said?
Yeah.
It doesn't make sense.
So do you understand that this times this is going to have to equal this times this? Whoops,
Yes, I
right?
understand that part.
Right? But notice though that this whole length of PR is not going to equal the whole length of ST. One was 10, one was 11. But the individual products are always going to be equal. Okay, let's take a look at this next example. For this one, you are trying to find the length of segment CS. Audrey, can you help me out with that?
Sure. So, I found x. You want me to tell you how?
Yes, please.
Okay, I said SC times CU.
SC
Yeah,
times CU.
yes. Equals BC times CT.
Okay.
And that's 5x plus 1 times 10 equals 14 times 15. And that's 15, or 5x plus 11 equals 210. and I subtract 11. Or 210. It's 210.
What, oh, 210?
Yeah. And then 5x equals 199. And then 5x, I got 39.5.
Everybody okay with this?
Yeah.
All good? Angelina, what's wrong?
First you have to distribute the 10 into the 5x.
All right, so back up here, we're gonna need to distribute that 10. So let's take it all back. Audrey, can you adjust?
Sure. 50x plus 10.
50x plus 10, because we're distributing, equals, what was 14 times 15?
210.
210. And then subtracting 10,
Yeah.
we get 50x equals 200, so x is gonna be
4.
4. Are we okay with this? All right, but is that our answer? 4?
No.
Nathan,
4 is the
Slatter?
X.
Okay. So what do we get?
20 plus 1.
So 21? So is it true that 21, which is this length, times 10, which is this length, is going to be equal to 15 times 14?
Yeah.
Are we all good with this? All right, because both of these equal 210, so it works. All right, so let's take a look at the definition of a secant segment. A secant segment is a segment of a secant with at least one endpoint on the circle. All right, a secant segment is a segment of a secant with at least one endpoint on the circle. All right. So I would like you to, what else? I've got external secant segments. That would be a secant segment that lies in the exterior of the circle with one endpoint on the circle. All right. Got some cool eye tricks.
She's giving it this shadow stuff.
Oh, I read that one.
Not weird. I'm just helping out.
Okay, so help me out with what are the secant segments here, Evan?
So, line KM.
KM,
Yeah.
we're going to say segment KM.
Yeah. Segment,
Yes, what else you got?
segment PM.
Segment PM. Okay,
And then, I don't know what the other's going to be. Or could you, oh wait, I'll do. Would line KJ and PM work, or those not be scans?
I feel like we should have 6. I think we should have 6 blanks here, don't you think?
That's a good question.
Like, what is it?
Oh, back it up to that. All right, so a secant. A secant is going to be any segment that goes through a circle in more than one point.
So there are no secants on the circle provided to us? That's like, there's no secants?
Yes, there is.
I mean, doesn't have to.
Oh, I thought you said,
It could, that could be a,
I thought they have to go through. It's just touching it, it's not going through.
all right, let me rephrase. It's going to be a line or a segment. A secant is a line or a segment that's going to touch a circle in 2 points.
Okay.
Does that make sense?
Yeah.
Okay.
So here, this one is touching the circle in 2 places.
Yeah.
So that makes this a secant. But I could call the secant segment AB. Or let's say I've got a point out here, I could also call it segment AC. That could be the name of this secant, right? Or I could call it segment BC. Does that make sense?
Yeah. Can you say?
Actually, it's 3.
No, BC only touches floods.
Yeah.
Oh, fact.
Which would be an external secant.
That's a category.
Segment secant with at least one endpoint on the circle. Segment on the, yeah.
With at least
Well,
one.
I think what they,
You said it was too.
yeah, well, that's, I'm giving you the definition of a secant, I guess, back it up. I'm giving you the definition of a secant line. A secant line would be a line that goes through a circle in 2 points, right? So if I throw this point over here on here as well, then I guess segment AB is a secant segment, and segment BC would be a secant segment, right?
It would be a secant segment.
Yeah.
There's at least one.
At least one, right, at least one endpoint on the circle. So I think KJ would work here, if I'm listing these.
So like,
And I think PN would work as a secant segment.
is there a difference between a secant segment and a secant?
I think if you just say secant, I think that implies a secant line. Yes. Okay,
Okay, is there like a difference between a secant segment and a secant line?
well, yeah, segment has 2 endpoints and it's just in between. A secant line goes on forever and ever.
Oh, yeah.
Okay, all right, so what about, okay, so if those are our secant segments, I'll leave it at that. So if those are our secant segments, then what are the external secant segments? Those are going to be secant segments that lie in the exterior, Maya?
Oh, J, M, and N, M.
JM, segment JM and segment MN. Are we okay with this?
Yeah, I guess.
Wait, why did we say jam? Oh, wait.
Okay, let's get to the theorem involving these. So that is the secant product theorem. And it goes like this. If 2 secants intersect in the interior of a circle, then the product of the lengths of one secant segment and its external segment equals the product of the lengths of the other secant segment and its external segment. And they are giving you a little clue here. Easiest way to remember this would be whole times outside equals whole times outside. That's the way to remember this. All right. So in this case, if we have segment secant AE and secant CE intersecting out here at point E, then we can find lengths of these segments by using that theorem that says whole, which would be segment AE, right, times, let's see, what am I doing? Times external segment, that's BE, everybody with me, is going to equal whole segment CE times its external segment, which is DE. Are we okay with this?
Yep.
That's our theorem. So it's whole times external equals whole times external. Whole times outside equals whole times outside. Let's put this to the test. Okay. Dominic, thank you for joining us today. Okay, so for this, we are going to do this. Can you help me out with filling in? I want you all to start like this. I want you to say whole times outside equals whole times outside. All right, can you help me out and fill those in for me, Nathan May? Which segment would be an external segment that we call a whole? Or the whole thing would be what? RT would be the whole. So I'm going to write segment length RT here times what would be the outside piece of that segment. RS equals what would be the whole on the other part. Andrew?
That would be QR.
QR would be a whole here, so QR. And what would be the outside piece of that? PR would be the outside piece. Everybody agree with this? Okay? And you're going to fill in some numbers for me here. What do you think, Ella?
5x times 5 equals 10 times 4.
Wait, so what's RT? What am I filling in for RT?
Oh, so 10.
10, all right, that's 10. RT is that whole length, so 4 plus 6. And how about RS?
4.
4 equals, what's QR?
5x.
5x. Is it going to be 5 times x or 5 plus x?
We added the other.
We're adding, so 5 plus x, just like we added 4 plus 6. So we want 5 plus x. Ella, keep going, please.
And 5.
And just 5 for the external piece. Are we okay with this? Do we distribute?
No.
Sure. You can distribute. You could do 5 times both of these. Can you help me out with solving this, Mitch?
40 equals 25.
40 equals 25 plus 5x. And we're going to solve this, how, Mitch? Subtract 25 from both sides. And 40 minus 25 is at 15. And then divide by 5, and we get x equals 3. Are we okay with this?
I did it a
Isabel.
different way, but I got the same answer.
What did you do?
Okay, so, when it said, 40, okay, I got 40 equals 5 plus x times 5,
Yeah?
and then I divided both sides by 5, and then I got 8 equals 5 plus x, and I subtracted 5 from both
All right, let me catch up to you. So you had this equation, 40 equals,
5 plus x times 5.
okay, and then you,
I divided both sides by 5.
okay, and then these 5's divided out.
Yeah.
So then you were left with
8 equals 5 plus x.
8 equals 5 plus x, and then you subtracted 5
Yeah.
and got x equals 3, just like we got here. Nice. Questions on this? All right. Okay, did we answer our questions? X is equal to 3, so are we done?
No.
No. So help in finishing this up. What do you think, Maya?
RT equals 10
RT equals 10, gotcha.
and RQ equals 8.
Equals 8, because 5 plus 3 is equal to 8. Are we okay with this? All right, and yes, Isabel.
Oh my God, really?
Oh, thank you. All right, okie dokie. So let's take a look at the next one. In this case, a tangent segment would be a segment of a tangent with one endpoint on a circle. So what are the tangent segments in this picture here, Rachel?
Segment BA to CA.
Segment BA and segment CA are going to be tangent segments. And that leads us to another theorem. This one's called the secant tangent product theorem. And it says if a secant and a tangent intersect in the exterior of a circle, then the product of the lengths of the secant segment and its external segment equals the lengths of the whole segment squared, or of the tangent segment squared. So in this case, here's your little hint for this one. Whole times outside equals tangent squared. All right, whole times outside equals tangent squared. So that means that AC, which is the whole, this is the whole, right, AC, times the external piece, which is BC, right, whole times outside, whole times external, is going to be equal to the tangent segment squared, right? Let's put this one into place. Are we good to go on?
Hold on.
All right, and so we're trying out this one, which says segment LK is a tangent of the circle. Find the length of LN. And just a reminder, we want whole times outside equals tangent squared. So I want you to all start like that and write whole times outside. Make that neater. Whole times outside, I'm abbreviating, equals tangent squared. Can you fill this in now with segment names? What is the whole segment? What is the outside segment? What's the tangent segment? Angelina?
LN times L, or LN times LM equals LK squared.
LN times, what was the external? LM equals
LK squared.
LK quantity squared. So the length of LN times the length of LM is going to equal the length of LK quantity squared. Are we okay with this? You're filling in expressions or numbers for us, Nathan Slattery?
Okay, for ln,
Yeah.
we can do 18 plus 3x minus 4.
18 plus 3x minus 4. Do people agree with that?
Yeah.
All right, and then what's your length for LM?
Just 18.
Just 18.
Yeah.
Equals, what's your length for LK?
4 squared.
24, and that has to be squared.
Yeah.
Everybody okay with this? All right, talking me through how to solve this, Olivia.
So, I did B2 that I distributed. Oh wait, no.
Can we clean this up first?
Yeah.
Like terms?
So it's 14 plus 3x.
Okay, so 14 plus 3x times 18 equals 24 quantity squared. So now what are we going to do?
So then 24 squared is 576.
576, okay?
And just distribute.
Okay, distributing the 18, talk me through that.
So 18 times 14 252.
252 plus
18 times 3 is 54x.
54x equals 576.
Yeah,
All right. Then we're going to what? Subtract
yeah.
252, a little help.
324.
324. And does 54 go into 324? 6? Everybody okay with this?
Yeah.
All good? So are we done?
No.
No. We found x, but we're supposed to be finding the length of segment LN. So a little help there. Carlina.
I plugged in, I did 3 times 6 minus 4 for to find segment MN.
All right. So what's that?
14.
14?
And then I added 18 to that to find MN.
18 plus 14 is that
32.
32 units, whatever that is. Are we okay with this?
Yeah.
All right, what else do I have for you good people? That's it. All right, so you have some homework and I have a worksheet for you.
End the video.
That's it. Thanks for watching.
Bye.
Have a great day.